So yeah, we're gonna discuss some basic concepts. Uh, Here first we have so we'll cover two things: why mobile is different and how the development life cycle changes on mobile development. So I'll keep it short and use an example. Uh, so I think we'll use the campus event app as an example that shows events and lets students RSVP. So first we have design for mobility uh, basics. So mobile is different because people use phones in real time situations, not in a quiet desk setup. So that changes what good design looks like. So why mobile is different is first an obvious reason: small screens. You cannot show everything at once, so you must prioritize what matters. And we have touch input. Fingers are less precise than a mouse, so buttons must be bigger and spacing matters. And then we have short sessions. Users often open the app for 10 to 30 seconds to do one thing fast. So and then we have unreliable conditions. So users often open the mobile app. Mobile users move around and may have weak signal, uh, no signal or slow data. So that's one issue. And we have battery and performance limits. So heavy animations, constant GPS, frequent network calls drain battery and make apps feel slow. So that's why mobile development is different. And there are challenges. So there are challenges for this, like keeping the app simple while still useful, and handling network dropouts effectively, and making the UI readable, easy to tap, protecting privacy when using location or device data, and also supporting different screen sizes and operating systems. So those are the main challenges. And we have some technical considerations, which is offline or low connectivity support. So what should still work without internet. And then we have performance, like fast loading, smooth scrolling, and then again battery use. You avoid constant background work. Security, protect logins and personal data. And again, different screen sizes, hardware, operating system versions. So for example, again in the example, uh, in the campus event app, the main task is you find an event and RSVP fast. So a good mobile design might show a simple list of today's events first, and use a large RSVP buttons, keep the event details clean and readable, and store the last loaded events so the list still shows when signal drops. So only request location if the user chooses events near me. So this is mobile thinking, fast, simple, and reliable under real conditions. So then the development cycle, life cycle. So the basic phases are similar to any software project, but mobile has some extra focus on, like devices, stores, or real world use. So what changes in planning is you plan for different phones and operating system versions from day one. You decide early if you need offline support, notifications, location, camera, or other device features. And you plan for privacy and permissions because mobile apps often request sensitive access. So for the event app, planning maybe includes which devices are supported, whether RSVP must be offline, whether push notifications will remind students before an event, what permissions are needed, if any. So what changes in UI design is, UI must be thumb friendly and simple. So navigation should be short and obvious. You avoid clutter because screen is small. So like for example, instead of a complex page with 12 filters, you might use a search bar, 2 to 3 simple filters, and clear categories like today, this week, my RSVPs. So in testing, So mobile testing is bigger than desktop because you test different screen sizes, different operating system versions, slow network, airplane mode, switching Wi-Fi to cellular, battery drain, performance, touch behavior, accessibility. So there are like a lot of things that goes into testing. Like for example, like we are testing a RSVP weak signal while signal is weak. The correct behavior might be, it shows RSVP saved while sync when online. So this is mobile friendly design that prevents frustration. So what changes in releasing on mobile usually means app store process, which is packaging, signing builds, you store review rules, privacy disclosures, versioning and update cycle. You also need to plan for bug fixes, and because users may not update immediately. So like for example, if you fix a RSVP bug, some students might still have the older version for a week, so you design the backend to handle older app version safely. So mobile design is different because mainly of small screens, touch input, short usage, unreliable networks, and device limits. So the mobile life cycle changes because you plan for devices and permissions early. Design for fast thumb friendly UI. You test across real conditions and release through App Store rules and updates. So it's a lot different when compared to traditional web development. So next we have mobile architectures and context aware apps. So uh, mobile architectures a mobile architecture is just how you organize your app's code so it stays clean, easy to test, and easy to change. On phones, architecture matters even more because phones have limited battery, limited memory, unreliable networks. So if your architecture is messy, the app becomes slow, uh, crashes more, and is hard to maintain. So we have few approaches here, few options, common options, which is simple single layer approach, which is everything is mixed together. UI, data calls, logic is in the same place. Works only for tiny apps, but it becomes messy fast. And then we have a layered approach. You separate the app into layers like UI layer, logic layer, data layer. This is common because it keeps responsibilities clear. And then we have MVVM or MVC style, which is common on mobile, which is basically UI handles display, a middle part handles logic and state, a data layer handles network and storage. This helps testing and keeps the UI from becoming a giant mess. Uh, and then we have, like for example, in the campus event app, UI layers show the event list and details. Logic layer decide how to show filters by date, handles RSVP rules. Data layer fetches events from the server and also caches them locally. So why architecture matters on phone? If the UI is calling the network directly, any slow network causes the UI to freeze. So if you separate UI from the data, you can show cached events quickly and update in the background. So this makes the app feel faster and more reliable. And then we have context aware apps. So context aware apps changes behavior based on user situation. The context usually mean location, time, sensors. Sensors is basically movement, step count, Bluetooth, a camera, microphone, those kind of things. So context aware does not mean collect everything. It means using context only when it provides real value. Like for example, in the campus event app, context aware features could be, the location. You show events near you or closest building for this event, and time, like showing starting soon events at the top. Uh, so yeah, sensors, if the user is walking, it offers directions and large tap targets. So key design concerns for context aware apps is privacy. um, you know, Location and sensor data can be sensitive. and you do not collect more data than you need. So usefulness, context features should solve a real problem. If it feels unnecessary, users will turn it off or delete the app. And then we have battery. So constant GPS tracking drain battery fast. So use and also use location only when user requests it, or use low power options when possible. So avoid heavy background work that saves a lot of battery. um, yeah, mobile architecture keeps your app clean and stable under mobile limits like slow networks, low memory. Context aware apps can be powerful, but they must be designed carefully so they are useful. It respects privacy and not drain battery. And then, so next we'll discuss about again two topics: web design pyramid and pattern based design. So, uh, so web design pyramid is a reminder that good web design is not just make it look nice. It has layers you must get right. If you skip a lower layer, the top layer will not fix the experience. So the five layers are architecture, navigation, content, aesthetic, and web app interface. So architecture is the overall structure of the site. It is how pages and sections are organized. Like if, for example, for a course site, a clean structure might be home, modules, assignments, grades, help, as you see that in your LMS. So if the structure is messy, students will not know where to go even if the site looks pretty. And then we have navigation. So navigation is how users move around the structure. You should be consistent and predictable. And then we have content. Content is what you actually put on pages and what how it is written and organized. Good content is clear, scannable, and updated. Like due date, for example, in the assignment page, good content would be due date, what to submit, grading criteria, rubric. So those kind of things. And then we have aesthetics. So aesthetic is the visual style like fonts, spacing, color, layout. It supports readability and trust. And then we have web app interface. So this is interactive part like forms, buttons, search, filters, feedback messages. It is how users complete tasks. Uh, and then we have pattern based design. So a design pattern is a proven solution to a common problem. You do not reinvent the wheel every time. You reuse patterns because users already understand them. So what design patterns are? Basically, it's reusable solutions, not exact code. They describe a typical problem and a typical fix. How to describe a pattern is you a simple way is to uh, describe a pattern is first is the problem, what issue keeps happening, and the context, where it happens, and then the solution, the standard approach, and then the results, why it works and how what it improves. Um, yeah. So web design pyramid helps you build the site in a right order so it works before it looks fancy. Pattern based design helps you reuse proven solutions, stay consistent, and avoid common mistakes that can frustrate users. So that's all for this topics.